Okay, so we have one more practice of rational functions where I take you through all the steps. And in this case, I think I've planned it so there are two vertical asymptotes, so we can see what happens when that is the case. So remember that our first step is, if possible, we want to factor the numerator and the denominator. So let's see if this is factorable on the top and the bottom. So x, let's see, we have a 5 and a 1, I think, because we want it to multiply to be -5. And yes, we can make it add to -4 if we do -5 and +1. On the bottom, that is the difference of two squares, so x plus 4 and x minus 4. Okay, so it totally factored, and notice that nothing actually canceled out. And that's why we do have those two vertical asymptotes. Okay, so first of all, we will practice by writing the domain. So remember that it's whatever is in the denominator. So x cannot equal -4 and 4. And because neither -4 nor 4 canceled out, the vertical asymptotes are x equals -4 and x equals 4. Okay. The horizontal asymptote, let's see if we have one of those. Okay. So notice that we're looking at the degree is 2 on the top, x squared. The degree is 2 on the bottom, x squared. So our horizontal asymptote, it's the leading coefficient over the leading coefficient. So that is y is equal to 1, because the leading coefficient is 1 in both cases. Okay, so that means that our slant or oblique asymptote, there's none. Okay, so let's look at the x-intercepts and the y-intercept. So the x-intercepts are where the numerator equals 0. So, because we're going to set the function equal to 0, so that's the x squared minus 4x minus 5 equal to 0. Okay, well, we already factored that, so x plus 1 times x minus 5 equals 0. So x is equal to -1 or 5. Okay, the two things that make this function 0, this equation 0. So our two x-intercepts are -1, 0 and 5, 0. Okay. Our y-intercept is where x is equal to 0. Okay. I actually think it's easiest to plug that back into the original function rather than in factored form, because this is 0, so the numerator is just -5, and the denominator is 0 minus 16, so just -16. So that's 5/16. Okay, so that would be the point 0, 5/16. Okay, time to graph. So first we're going to graph those vertical asymptotes. Ooh, I thought it was looking good, but it spoke too soon. It's okay. Also the -4. There we go. And we have a horizontal asymptote at x is equal to 1. There that is. Now hopefully our intercepts will help us. Okay, so our first intercept is at -1, 0. And our second intercept is at 5, 0. And our final intercept is 0, 5/16. So that's in here somewhere. Okay. Okay, so they do help us a little bit, but I think we're still going to have to do a little work with the limits to finish this problem off. And alternately, again, since you are home and have a calculator, you can use your calculator to take a look at it to see where these things go. So the first thing is, notice that this part needs to go here and here. Okay, the 4 from the right limit is clear. Because of that point, there's like nothing else it can do. This part I think is a little unclear because it could go up here or it could go back down. Oh, could it go back down though? Because if it went back down over here, wouldn't there be another x-intercept there? Okay, so technically we also know that this needs to go up towards this asymptote, and this needs to go down towards this asymptote. Okay, so if you weren't sure about that one though, like let's say you just weren't positive, confident on that, what you would do is look at the limit of the function as x approached 4, and we're looking at it from the little bit to the left of 4, so 4 negative. Okay, and so in other words, we would want to put something a little smaller than 4 in. So I would put in 3.9. Okay, I would put in 3.9 to my function. And I guess it's easiest usually to do that in factored form. So if I'm putting in 3.9, I'll do it down here because I don't need a limit over here because I know them. So I have some space. Okay, so I'm going to put in 3.9 plus 1, 3.9 minus 5 over 3.9 plus 4 and 3.9 minus 4. Okay, remember we don't really need the actual numbers, we just need to see like are things positive and negative. So this first number would be positive, and then 3.9 minus 5 would be negative, and on the bottom 3.9 plus 4 would be positive, and 3.9 minus 4 would be negative. So a negative divided by a negative is equal to a positive. Okay, so that tells us that this limit is going towards positive infinity, and that's why it's going up right here. Okay, and then again, we could do the same thing right over here, but think about what number we would plug in, right? I would plug in negative 3.9 because I would want it to be slightly to the right of negative 4. So slightly larger than negative 4. All right, now the other part of the graph that I really don't know, like I'm guessing it's over here just because it would look nicer, wouldn't it? Wouldn't it look better if it's up here because of like kind of some symmetry going on a little bit? But I don't know for sure. It could be down here. So I need to look at the limit of g of x as x approaches negative 4, and that again is from the left because it's a little bit more negative. So the number I would want to plug in would be like negative 4.1. Okay, so plug that into the factored form. So negative 4.1 plus 1, negative 4.1 minus 5, negative 4.1 plus 4, and negative 4.1 minus 4. Okay, so the first number would be a negative number, the second number would be negative, the third number here slightly negative, and this number here clearly negative. Okay, so that's actually 4 negative signs, right? So this is really a positive divided by a positive. That is total a positive. Okay, so in other words, our limit is equal to positive infinity, and the graph is going up at this point. So I know that part is a little complicated, right? But you really are just plugging in numbers and seeing what the function says, whether it's a positive number or a negative number.